What is normal force? To explain what normal force is, we need to first explain weight. Weight, or the force of gravity, acts on all objects on Earth at all times. This downward force needs to be counteracted to prevent objects from falling. So let's say this is a table, and you put an object on the table. The surface of the table exerts an upward force to support the object. This force is called the normal force, and it acts perpendicular or normal to the surface. The normal force balances the object's weight when it is at rest on a flat surface. So if this is the object's weight, mg, N is equal to mg. However, its magnitude can vary depending on the angle of the surface or additional forces acting on the object. So here's an example where the object is on an incline. Let's derive the normal force in terms of weight. First, let's define a coordinate system. To make it easier to calculate the normal force, I will choose this coordinate system. So now let's find the weight components parallel and perpendicular to the surface. To find each of the components of W, we need to first find the angle that they make with W and then use trigonometry to find each of these components. So what is the angle theta? We need to find the angle theta in terms of the angle alpha because alpha is the angle of the incline, and usually in problems we know that angle. So let's find theta in terms of alpha. Okay, so to find theta, let's take a look at this red triangle. This is a right triangle, which means alpha plus this angle would be 90 degrees. Let's call this x. So alpha plus x is 90. And also, if you look at this angle, this is also 90 degrees, right? Because this is the direction that we chose our coordinate system to be. So this is also 90 degrees, which means x plus theta is equal to 90 degrees. And if we solve these two equations, that would give us alpha is equal to theta. So this angle is actually alpha that we already have. Now let's solve for perpendicular and parallel components of W. From trigonometry, we can say that the perpendicular component is equal to W cosine of alpha, and the parallel component is equal to W sine of alpha. So if the perpendicular component is equal to W cosine of alpha, and there is no movement in the y direction, then N is equal to the perpendicular component of weight, or N is equal to W cosine of alpha. What is tension? A tension is a force along the length of a medium, such as a rope or a cable. It is important to note that tension is a pull outward along two ends of a rope. For example, this rope is attached to a box with weight W. The tension force along the rope pulls outward at each end. If the object is not moving, or if it is moving with constant velocity, then the tension force in this case is equal to W. What is friction? Friction is the force that opposes the motion of one surface as it moves across another. There are different types of friction force, two of which are static and kinetic frictions. Static friction is the friction that keeps an object at rest when a force is applied to it. The object stays at rest until the force becomes so large that it overcomes the friction. When there is no motion between the objects, the magnitude of the static friction is where μs is the coefficient of static friction and n is the magnitude of the normal force. Once the applied force exceeds Fs maximum, or μs times n, the object will move. Once the object is moving, there is kinetic friction. So what is kinetic friction? Kinetic friction is the friction that acts when an object is already in motion. Once the object is moving, kinetic friction resists its motion. The magnitude of kinetic friction is given by where mu k is the coefficient of kinetic friction and n is the normal force. What is drag? Drag is a type of friction that occurs when an object moves through a fluid like air or water. It is a force that opposes the motion of the object and slows it down. Drag is essentially the resistance force exerted by the fluid on the object moving through it. It acts in the opposite direction of the object's motion. When the object moves quickly in a medium, like air or water, the motion of the object is mostly affected by its own momentum or inertia, rather than the fluid's thickness. This force is given by where c is the drag coefficient, a is the area of the object facing the fluid, and rho is the density of the fluid. Now, if the object is very small and going very slow in a denser medium than air, the relationship between the force and the velocity is given by Stokes' law, where r is the radius of the object, nu is the viscosity of the fluid, and v is the object's velocity. What is elastic force? Elastic force is the force exerted by an elastic material when it is stretched or compressed. This force acts in the opposite direction to the applied force and tries to bring the material back to its original shape or size. For many elastic materials, the elastic force follows Hooke's law, where del L is the amount of deformation, like the change in length produced by the force, and K is the proportionality constant that depends on the shape and composition of the object and the direction of the force. When a force is applied to an object, like a rod or a wire parallel to its length, a change in length is produced. This change in length depends on the applied force, material's original dimension, and its elasticity. The equation for change in length is given by where del L is the change in length, F is the applied force, Y is the Young's modulus that depends on the substance, A is the cross-sectional area, and L0 is the original length. What is stress and strain? The ratio of force to area, or F over A, is defined as stress. And the ratio of the change in length to length, or del L over L0, is defined as strain. So from these two expressions and this equation, we can find Okay, I hope this video gave you a quick review of some of the most common forces in physics. If you have any questions, feel free to ask in the comments, and don't forget to subscribe so you won't miss my next video on circular motion.